Hello, Tim's Tips here. I'm quarantining here in Pennsylvania, arriving from a trip from Arizona, and I have another day to go in my quarantine, so I thought I'd do a video here about my 220 volt processing here in the van. I have a unique way, nothing like it in the world, of a 220 volt processing split phase, so I can handle either one 120 volt leg or two 220 volt legs, and I can process that through a relay switching action here. Have protection relays that process the 220 and make sure it's valid before the van handles it. So here we go. First, I want to show you here the cord reel I got is a 220 volt regular RV shore power plug here that plugs into any campground, and it comprises of two basic legs, two 120 volt legs as shown here, and then the W is the neutral, G is the ground, of course. And so you can tap power off of either of these. Second thing I'm going to show you, coming over here to the breakers. Each one has a 50 amp breaker, hence the 50 amp shore power, and those are ganged breakers, so they work together. And then they're split up into two, I call it 125 VAC, volts AC legs there. I kind of use that interchangeably with 120. They both go over to what they call a protection relay. So both legs go in there, and the protection relay delays, checks the power, makes sure the voltage is right and the frequency is right. And if it's okay, it goes into the automatic transfer switch, which then transfers it to the loads, which includes the mini split system here, or my true instant hot water system. So that's the only requirement I have for 220. So as we pull back here, now we also tap off the two 120 volt legs, and we tap just one of those off into the 120 volt automatic transfer switch. If that is when it gets applied to the transfer switch, it transfers it to the outlets and all the 120 volt appliances in the rig. So as the 220 volts is also applied to another protection relay, K4, which if the power is okay, it energizes K3, and that basically switches both legs. There's already one 120 volt leg, but it switches both legs into this relay K2. And what that does, it's normally closed contact, just basically transfers that power to K1. And so then, as it's shown here, both legs go into K1. As long as the charge is enabled there in the upper right, I'm going to show you the charge enable line from the BMS, battery management system, says it's okay to charge the Tesla Model 3 battery. That power is then applied to, from the Elcon, it's an Elcon 6.6 kilowatt charger. That's applied to the Elcon, and then it starts charging. It's also controlled by CAN bus, so it's controlled two ways, both through software and through this AC power relay. So I can also charge either 120 volts AC. The Elcon works 120 or 220 volts. So either way, if it gets, as long as that L1, that line 1 is hot and has voltage on it, it will charge. You might ask, why did I do this monstrosity here? It's because I used to be, once upon a time, a great relay logic engineer, and I also know 220 volts. I've done wiring in my house. I've wired an addition, so I knew how the systems work, and I wanted to be safe and reliable here. This has to work since it's a house. I wanted to use split phase. I wanted it to be handled automatically, relatively automatically, a combination of inverters and shore power, and inexpensive, under $1,000 for a 4 kilowatt plus inverter, and use just the standard RV campground or household plugs, including granny power, power that might be limited to 10 to 15 amps. So this system accomplished those goals. So why did I strike out on my own and design and build these circuits? It was because the vendors just didn't have the capability to do this. So I looked at Victron, looked at their split phase capability, which is you had to buy 2 inverters and sync them up, and it didn't do what I needed. The 96 volt DC input from the Tesla Model 3 battery was not available on the Western market, and but it was readily available on AliExpress. I also looked at these Autotransformers, the ability to transform the power into 220. I could have done that, but I figured for a lot less money I could do it with some relays here, very simple relay logic, and just using high power relays and logic. So these high power relays, you know, $20 or less, and I did not want to use the Autotransformers to step up or step down any of the voltages because of the cost and weight of these Autotransformers, and the fact that the more heavily you load them, the less voltage you get and less efficiency you get. This is a photo I took of out in Arizona. Just wanted to recharge my batteries. I hope you subscribe to my channel, and we'll see you next time.